Okay. Let me also ask you guys, are you getting the notifications, the announcements from the course website? Is it coming into your email inbox?
Yes, sir.
Yes, sir.
Okay, great, great. Uh, all right. So a very quick recap of what we talked about in the last class. So in the last week, uh, so we are studying this classic paper by Crawford and Sobel, which models in a very stark way strategic communication between two players, two agents. For example, a prime minister receiving advice from an expert on some area, like a defense expert, an economic expert. And the problem becomes interesting when the expert knows relevant information about the state of the world, um, because the expert has training in that discipline, has the time to sort of pore over the evidence, the research, um, and so the prime minister relies on the expert for fine information about conditions on the ground, right? So if it's a defense expert, national security advisor, what is the summary of intelligence reports about the level of external threat? That is the state of the world that the decision maker wants to know. Similarly, if the decision maker is trying to decide on, let's say, the social sector budget, the decision maker wants to know what is the, poverty level, what is the unemployment level, and that will determine how much money is allocated towards welfare programs. Right? We have had COVID, which created a lot of distress and displacement, and there was a lot of talk about how to mitigate those effects. And as you know, last year, pre-budget, the government significantly increased allocation to NREGA because many migrant workers from cities went back to villages. So to give them support, it was increased. So the government always needs this sort of information to make budgetary allocations and other policy decisions. And experts have to be relied on. Now, the problem is interesting when the expert has somewhat conflicting preferences with the main decision maker, with the prime minister, right? So, for example, the national security advisor could be a defense hawk. Even if the prime minister and the NSA had the same information, they may not completely agree about how much money should be allocated. Similarly, for the social sector budget, maybe the advisor is somebody who has more of an emphasis on redistribution than growth, and would therefore, for the same value of theta, the state of the world would like to allocate more money to the social sector budget and welfare programs. So that's the problem we are studying. Yeah. So what is the upshot of the Crawford-Sobel model? It's the most simple, stark model of strategic communication. There are two players. One player can make the decision, has all the power. The other player has all the information about the state of the world and can convey that information through cheap talk messages. And we saw the equilibrium takes the form of a partition. Okay, it is not credible as long as there is some conflict of interest between them, as long as that B parameter is strictly positive. You cannot have a fully revealing equilibrium, right? The advisor or the expert will not be able to communicate in a credible way the exact value of theta. That's not possible. But that doesn't mean everything is lost. So in the discussion from last week, we saw that it is possible, unless the bias is very, very large, in which case, the only possibility is a babbling equilibrium. But for relatively small values of biases, you can construct equilibria where the possible values of the state of the world is broken up into a number of intervals. And the message conveys which interval theta lies in, not its exact value, but which interval. Right. Now, then we went on in that video, the last of the videos, I talked about how to analyze welfare, right? And you can think of welfare at multiple points in time. You can think of the sender's welfare, for example, after the sender learns the state of the world. That's ex post welfare. But you can also calculate the sender's welfare before the state of the world is realized, right? And of course, before the sender sends his message, right? And in some sense, that's the relevant yardstick to use. Because if you think of these problems as recurring problems, every year we'll have this sort of, before the budget, allocations have to be decided. So it's a long-term, repeated kind of problem. In that case, it makes sense to judge the welfare of the different parties by the criterion of ex-ante payoff, both for the sender and the receiver. And it seems a little odd to apply that to the sender, because the sender will eventually learn what theta is before sending his message. But nevertheless, looking ahead to future years, over the next 5 years or 10 years, what would be relevant is the expected ex-ante payoffs. So I showed you how to calculate that. And the basic point is that although ex post, there's a significant conflict of interest between sender and receiver, ex ante, there's practically no conflict of interest. Yes, because if you recall, these are the expressions we derived. The expected payoff or expected disutility here, ignoring the minus sign, expected disutility of the sender in the overall game is the receiver's expected utility plus this B squared factor. So things which will improve UR will also improve US in general. Yes, it depends on what exact thing the thing is, but they're positively correlated. Yeah, and that creates this interesting issue of commitment. This is one of the most important kind of ideas in basic game theory, that when we play a game, the fact that we cannot commit to our future behavior often reduces our payoff ex ante at the beginning of the game, right? And often, if players can tie their own hands or reduce their options, they're better off in the game. Yes. One classic example which you come across in introductory game theory when it's being taught is the example of Fernando Cortez, the Spanish general. Right? The Spanish army had come from Europe and had landed on the coast of South America, and they were about to fight the Incas, the Native Americans. And before the battle, the Spanish general burnt his own ships at the harbor, right, in a highly visible way. So the Inca army and their chiefs could see that these guys are burning their ships. And that seems like a suicidal act, an act of self-destruction. They had sealed off their own exit option, right? If the battle went bad for them, they didn't even have the option of boarding their ships and escaping. They had to fight till the death, as it were. But that made a very powerful impact, because the Spanish army fought very hard because their exit option was taken away, and they eventually won the battle and so on. So burning of the ships is a classic example that is often cited of a commitment device. Yeah. Just saying that, we will fight till the end and we will not run away in our ships is not going to be credible. So you have to do something hard and tangible to make the commitment stick. Okay, so then what was the sort of main upshot? So I discussed that. So today I'll elaborate on that. And let me introduce sort of, all the different pieces that I'm going to talk about today. Let me introduce it as a theme. Our theme will be rights as self-interested gifts. Okay, they're very kind of rights, right? So the government passes the Right to Information Act. So that means that the government or the state is giving the citizen the right to know everything relevant about government policy. Yeah. So that's a right which has been granted. If we have a constitutional amendment or a clause in the Constitution which gives citizens the right to free speech, that you can speak your mind about anything, express any opinion without being prosecuted. The First Amendment of the American Constitution is famously gives this free speech guarantee. Right? It's the first item on the so-called Bill of Rights. And in our Constitution too, we have a similar clause, although it's more qualified, that you have the right to free speech unless you impinge on, enmity between different groups, etc., etc. So ours is a little less strong than what they have in the American Constitution, but we have some version of it. Yeah. So all of these are rights. So here, these two examples are where the government or the state is giving these rights to the citizens. Similarly, if you look at the history of democracy, right, the European countries at some point had monarchies, and then they had oligarchies, and most citizens didn't have the right to vote. But then the franchise was gradually expanded, right? More and more people were given the right to vote. Women didn't have the right to vote at the beginning of the 20th century in most Western democracies, but early in the 20th century, even that was granted. Right? Now, how do we think about these issues of granting of rights? Now, of course, the party who has been given the rights will be better off. That is trivial, obviously. Yes. When women didn't have the vote and then they got the vote, of course, that means the democratic process have to take into account now the interests of women, right? And that will be better reflected, and that will make women better off for sure. Will it make men better off? Will it make, the powerful ruling oligarchs better off? That is a more trickier question. So the point I want to make is that often by extending rights to various people, right to information, right to take certain decisions, right to vote, etc., it can be a win-win. So the party who's receiving that right, of course, will be better off, but the party who's giving the right can also benefit. And this, I think, is not appreciated enough. So that's why I wanted to emphasize this point in today's lecture, that it can be a win-win outcome, right? So when the European monarchs and oligarchs gave the vote to ordinary citizens, it perhaps, one can make an argument, a case, that it may have served even the self-interest of those monarchs and oligarchs. Somehow they also became better off in the process, right? Now, we can create, or we can suggest several reasons why that may be so, and I can perhaps come back to this question later when we study information aggregation and topics like that. You'll see other arguments why one can make a case like this. Right now, I'm going to talk about cheap talk-based sort of arguments. And going back to our cheap talk game, okay? The fundamental problem there is that information and authority means the power to make decisions. Information and authority are vested in different players. The one who has the power to make decision doesn't have the information, and the one who has the information doesn't have the power to make decisions, right? And in some sense, the upshot is that we have to redesign institutions so that this information and authority do not remain compartmentalized like that, right? So maybe we have to bring information to those who have power, or we have to transfer power to those who have information. And that'll, in many situations, be better for both parties, not just one party. And the second point to emphasize is that this requires commitments, like, burning bridges, burning ships, passing a law, an act, etc. And if everybody realizes this sort of long-term objective, then this kind of transfer of power can happen without conflict. That's another point to note, if it's a Pareto improvement at the end of the day. Now, the various kinds of this transference of rights or conference of rights can be thought of. One is delegation, right? So power and information, if they're initially separated, you can transfer power to the informed party. And that's what is delegation. So in our game, suppose the receiver can hand over the keys to the sender, as it were, can let's say, write down a binding promise, a law which says that the sender will can choose the action, and the receiver will not interfere with that choice. Yeah. Now, that creates a trade-off. So if the receiver is thinking that should I transfer the power to the sender, he has to face this trade-off which he has to resolve. There's a plus and there's a minus as far as the receiver's interest is concerned. If he transfers power, the decision-making will be more informed. Remember, in the cheap talk game, information gets coarsened. Knowledge about theta doesn't pass perfectly to the receiver or the decision maker. It's broken into these broad intervals. And within the interval, what the exact value of theta is remains unknown. So in the cheap talk game, decision making is relatively uninformed. Yes, not entirely uninformed, but relatively uninformed. But if the sender is given the power to choose the action, then small changes in theta will affect the decision in a small way, right? The decision will be extremely sensitive to what the state of the world is. So it'll be a more informed decision. And that's good for everyone, including the receiver. So that's the plus side. The minus side is, of course, that making the decision agree with the receiver's preferences, meaning that the action choice will be systematically distorted towards the sender's preference and away from the receiver's preference. So it's a trade-off between informed decision-making and distorted decision-making. Yes? Now, in which way will it be resolved? In our uniform quadratic model, we can show that almost always delegation will be better. Yes. So let me show you with pictures what really the trade-off is. So suppose the receiver doesn't delegate and chooses to play the cheap talk game. So then we have these interval equilibria, right? So for example, just for illustrative purposes, suppose the equilibrium has 3 intervals. So 3 messages are sent out. And the action chosen corresponding to each message is the midpoint of the relevant interval, right? So on the other axis, it's the height of these red lines. So this step function tells us the mapping that arises in equilibrium between the state of the world on this horizontal axis and the action that gets chosen, which is on the vertical axis. It's a step function, right? As we cross from one interval to the other, the action changes discontinuously. It becomes the midpoint of the next interval. So that's the correspondence. On the other hand, if the receiver delegates the decision-making, then what will the graph look like, right? The action state graph, right? How does the state of the world translate into some action? That becomes an entirely different thing. And that's now by this sort of parallel, this sort of blue line, which is parallel to the 45-degree line. Why? Because now the sender has complete freedom in choosing the action. The sender will always choose theta plus b. And this line is really the map, the graph of theta plus b, right? It's b distant above the 45-degree line. So now ideally, what does the 45-degree line represent? It represents ideally what the receiver would want the action state correspondence to be. Remember that the receiver's optimal action or bliss point is always theta, the state of the world. Okay, so if he knew all the information from the outset, he would basically choose the 45-degree line as his decision-making rule. So under delegation, he gets a line which is just uniformly shifted above. And under cheap talk, he gets this red step function. So the question is, all things considered, integrating over all values of theta, which is better? And you can see that the answer is not immediately obvious, right? I can show you some values of theta where the red line is further from the 45-degree line than the blue line. But then on the other hand, there are other values of theta where the blue line is closer to the 45-degree line. Okay, so if we integrate, what happens? Well, for that we have to do these calculations, and that was what was there in the lecture slides, in the lecture videos that you saw. We derived these expressions, if you will. So this is the receiver's payoff, right? And as you can see, if n is 2 or more, then the second term itself is bigger than b squared. And remember, this is a disutility. So we have a second term which is bigger than b squared plus another term. And so under cheap talk, the overall disutility, expected disutility, is higher than under delegation. Under delegation, the disutility is simply b squared, right? There's always a gap of b between the ideal action of the receiver and what the sender will choose. Now, there's this paper by Wouter Dessain on your reading list, which gets into this question. It's called authority versus delegation. And it shows in the uniform quadratic case, which we are dealing with, the result is there, right? You just look at those expressions for welfare, and it follows straight from there. So in the uniform quadratic case, delegation is better for the receiver than retaining authority whenever there is a non-babbling equilibrium in the cheap talk game. Yes. Which is to say, whenever b is less than 1/4. In fact, if b is a little higher than 1/4, not too much, but a little higher, even then, delegation is a better choice, right? Only when b is very large will the receiver not want to delegate. But for those values of b, if he doesn't want to delegate, the cheap talk game only has a babbling equilibrium, right? So not delegating there amounts to essentially ignoring all information and just ignoring the presence of the sender or the expert or the advisor, and just choose half as the optimal action, right? And Dessain sort of extends this result from the uniform quadratic case to more general preferences where the preferences are distance-based or metric-based, meaning the difference between the ideal action and the action chosen is the only thing that matters. That gap is the only thing that matters. So it could be the square of that, it could be the cube of that, or some higher power, or some kind of general polynomial, what have you. As long as you can express everything in terms of that gap, the preferences, then these results go through. And particular Dessain shows that for very small biases, delegation will be infinitely better. So this gap, the ratio between this gap and the bias factor B will be infinity. So if you want to play the key cheap talk game, the disutility will be infinitely higher. That's the result over there. Okay, so this kind of ties it up. The next slide sort of says what I just said a moment ago. And in particular, what is the threshold value above which delegation ceases to be the optimal thing to do? And that's 1/√12. Remember that, we described that so 1/12 times x squared is the variance of any interval, right, where x is the size of the interval. So for the whole interval 0 to 1, the 1/12 is really the variance, and therefore the disutility if the receiver ignores all the information, right, and just chooses half, then his disutility will be 1/12. And if he delegates, then his disutility will be b squared. So as long as b squared is less than 1/12, delegation will be optimal. Okay. Any questions? No?
Sir, I was like wondering, shouldn't we consider like this model doesn't talk about what should the ideal theta be for the society? Like in our defense budget example, like what should the best theta be for like the people of like we are only considering the payoffs of the sender and receiver only. Why so?
You're not interpreting theta correctly, right? Theta is a state of the world. Theta is something over which society has no control. So for example, theta is, think of the example I've been talking about, the level of external threat to a country.
So I mean like the best action for the society then.
A,
Uh,
yeah, okay.
yeah,
So what is your
for the
question?
society. So in that sense, what should the best action for the society be when theta, like the receiver and the sender have a bias, right, of optimal action? So
We are going to be agnostic about that. Okay, the structure that we have built here, um, the main point is that if the receiver and the sender have different preferences, then there will be information loss, right? Not all information can be credibly conveyed, and therefore there will be information loss. Um, Now, that is the tangible point. Now, in some applications, in some examples, you may be more sympathetic to the receiver. In others, you may be more sympathetic to the sender, right? You may think that, oh, society's sender better represents society's interests in some example. In another, maybe receiver does. In yet another example, and I'll come to one in a moment, society's interests may be different from sender as well as receiver, okay? In some sense, we are saying that in this sort of strategic communication context, it doesn't even matter, right? There are arrangements which makes everybody better off. So take that result, the delegation result. The delegation, under, unless the gap is too large, that delegation actually makes both parties better off. Now, if receivers' preferences are more aligned with societies or senders, how does it matter? The delegation arrangement, transferring power to the more informed party is a win-win. And therefore, whichever side society is on, it's a win for society too.
yes, sir, that makes sense.
Yeah. That's
Thank
the
you.
remarkable thing, because one of the things we often get trapped into, or people often get trapped into, is some sort of zero-sum thinking, that every conflict situation is zero-sum. If one player loses, the other gains, and vice versa. Many interesting games have this combination of common interest and conflict, that there are certain changes you can bring about in the rules of the game or the arrangements of the game, which will be win-win for all parties. And in some sense, the message here is that there are possible win-win possibilities over here through things like delegation and so on. Yeah.
Excuse me, sir.
Yes.
So I want to ask that when we are talking about the mechanism of commitment, that there's a tension between ex ante and ex post motives. So, sir, for example, if you're talking about honesty is the best policy ex ante, but not ex post from the sender's perspective. So, sir, I'm not clear that why are we saying that the sender has an incentive to deviate to dishonesty ex post? Like, what are the factors that will drive him? Because isn't it like in the cheap talk game? He's just anyway adding to the variance when he is deviating to dishonesty.
Yes, yes, of course. So, so, so before the sender learns the realization of theta, he wants to inject himself with a truth serum, write down a Right to Information Act, so on.
Yes, sir.
Sense in which he. Now, what happens after he learns theta? Okay, um, at that point, if he can, for example, if the truth serum wears out, or the Right to Information Act has these loopholes and workarounds, let's say, suppose it has not been written tightly, so you can refuse an information request or not be totally transparent. Suppose there's that sort of room. Then after the sender learns theta, the sender has an incentive to misreport it, right? The sender knows that I want theta plus b. The receiver, if I tell the true exact value of theta, the receiver will only choose theta. So he wants to underreport theta. Over-report theta. Instead of when theta, let's say the bias factor is 0.1, right? So when the state of the world is 0.3, and he learns that, he would like to report it as 0.4, not 0.3, because then the receiver will take exactly the action which the sender wants. So if the commitment is leaky, it has cracks and holes in it, and it can be worked around, then after the fact, he will actually take advantage of that.
Okay, all right, sir, I got it. Thank you.
Yeah. Okay, now, so far we have been only talking about two options, two ex-ante commitment options. One is to not commit to anything. So the receiver says, you give me a chief talk message, I'll make the decision. Or he totally and completely delegates to the sender. He says, okay, sender, you decide what action should be chosen. A third possibility is delegation. Well, there are other possibilities. So let's talk about delegation. What does delegation mean? Delegation means that the receiver brings in a third party and gives the decision-making authority to the third party. Yes. For example, the prime minister, aware of all these strategic possibilities, says, okay, I'm going to appoint a defense minister. I'm giving up my authority over what the defense budget should be, because there's this credibility issue with the national security advisor and what he advises me. So I'm going to install a defense minister. The defense minister will have complete freedom in choosing the defense budget. Okay, and the defense minister will communicate with the national security advisor, the defense expert who knows what the external threat level is. And similarly, or the prime minister can say, okay, I'm delegating decision making to the finance minister. The finance minister will talk to the economic advisory council, and the finance minister will decide about the size of the social budget and so on. That's delegation. Yes. And it's strategic delegation. So the way we can think about it is that there's a whole range of these intermediaries or third parties to whom decision-making authority can be given. A whole range in what sense? In the sense that they have different values of the bias parameter. Okay, so the prime minister can bring in an intermediary whose bias is exactly his, namely 0, or the sender's, namely B, or something in between, right? So in general, it can be some B prime. And if there's a whole lot of potential candidates, that means, mathematically speaking, the prime minister can create a third player with a bias B prime, where B prime is a continuous choice, right? So that's the delegation game, where, that's the intermediation game, which is a more general form. Now, when you can bring in these third parties, one of the options is full delegation. One of the options is to choose B prime equal to B, which means effectively you are not using a third party or giving decision-making power to the sender himself. But if B prime is in the open interval 0 to B, right, that means you have genuinely chosen a third party to influence outcomes. Yes. So the question is, in this game, everything is well defined, right? If you think of it as an optimal choice of B prime on the part of the receiver in the very beginning of the game, then do you always have corner solutions? Or can you sometimes have strictly interior solutions? That means sometimes bringing in a third party is indeed beneficial. Now, this idea of delegation, it's one way of achieving commitment, yes? and it's widespread, right? So for example, central bank independence is one kind of commitment which governments exercise in a modern economy. Yes. Essentially, if the treasury or the finance ministry has complete power to over the money supply, then whenever there is political pressure or whatever, elections, there's too much of a perhaps incentive to print money and impose an inflation tax on citizens, and that would have a discouraging effect on investment and so on. From that came the idea of central bank independence, that there's going to be a central bank governor who will have secure tenure for 5 years and will have a narrow mandate, like keeping inflation down, for example, inflation targeting and that sort of thing. And the idea is that by offloading the decision-making power about money supply and interest rates to somebody else outside of government and outside of the treasury, there are benefits for everyone, including the treasury itself, because it allows the treasury to achieve a certain commitment over the money supply. So it's the same idea that we're bringing in here. Yeah, commitment through delegation or intermediation, if you will. So I will not sort of show you the details of the math here. I'll just tell you the result. What Desen shown in his paper is that in the uniform quadratic version, there's a range of values of B where the optimal choice of B prime, the optimal choice of who will make the decision, is strictly interior. B prime is strictly less than B, yes, but strictly greater than 0. So you indeed want a genuine third-party option in these cases. Questions? Is that clear, what I just said? I'm not going to show you the proof of this. I mean, if anybody's interested, we can go through that later. Again, there's a trade-off. If you choose a B prime, which is far away from 0, that means you're tolerating a lot of distorted decision-making, right? I should have said that the way this thing goes, right, choosing this third party, the third party whose preferences are captured by B prime plays the cheap talk game with the sender, the original sender, right? And chooses an action based on that. So the relative bias between the third party who has been selected and the sender is B minus B prime. So when those two guys are communicating and playing the cheap talk game, then it's basically a cheap talk game with bias, not B, the entire original bias, but bias B minus B prime. Yes, and that is what the gain from intermediation is, because the bias is now smaller between the intermediary who has been chosen and the sender. Therefore, their communication is more informative, has more intervals than the original game between the sender and the receiver. So that's the plus. The minus, of course, is that this intermediary will make choices of actions which is based on her preferences. So there'll always be B prime distance away from what the original receiver would have liked. So you have more informed decision making, but in the process, decision making is more distorted from the receiver's point of view. Okay. Right. So now let me move on to a more general mechanism design problem in this context, right? You might say, okay, you have talked about one option, which is the receiver just empowering the sender. That was the first thing we talked about. The second thing we talked about is the receiver empowering a third party, not the sender, but a third party. And the third party then sender then talk and communicate, and the third party makes some decision. So that could be an even better improvement. Now, pushing this to its limit, we can ask, suppose the sender can commit to some mechanism. Yes. What is a mechanism? A mechanism is an action choice rule. So the receiver, before the game even starts, says, okay, I am writing down this function. For every message you send, think of the message as a claimed value of theta. I will choose an action as described by this function. Yes. Suppose he writes it down on a legally binding piece of paper and it's sealed and approved by courts. What kind of function will he want to commit to, the receiver? That's the question. Yeah. In mechanism design theory, there's the revelation principle. The revelation principle says that without any loss of generality, really, we can restrict attention to truth-telling mechanisms, truth-telling direct mechanisms. That is to say that the message strategy of the informed party will be to report the true value of theta and not change it around. Okay, we have talked about this before. Let me just refresh your memory. We will not go into any proof of that, but this is the famous revelation principle. So that's what we can bring in here, right? So this function should be such that for every theta, the sender has an incentive to report it truthfully. Now, in this context, we don't have money, right? In many of these mechanism design or contract theory problems, you have money. There will be some action or decision, but there will also be money. So here, let's keep money off the table, yes? So then we can think of the mechanism design problem very simply as choosing a set of permissible actions, yes? So let's say, we have created a mechanism which looks like this. Here's a set of messages or thetas, claimed thetas, if you will. And the corresponding actions look like this, let's say. All right. These are the actions. So this is our A star M function. So now there's a range of A's which might arise for some claimed value of theta. Okay, so there's this range of actions. So we might think of the problem as essentially the receiver saying that, okay, I'm allowing these actions and nothing outside this set. And I'm giving you a more restricted delegation. I'm asking the sender to choose the action, but subject to the condition that the action cannot be chosen outside this set. All right? Everybody see that? Because if the receiver creates a mechanism which specifies this action choice rule, that, if you report various thetas, I'll choose an action according to this function. Now, whatever be the true value of theta, the sender can always induce an action that is in this set by the appropriate message. Suppose the actual theta is here, right? For that value of theta, if the sender wants not this action, but let's say some other action from within this set, then he can always get that other action by sending the corresponding message. All right. So that means instead of thinking of, choosing a mechanism which is described by this sort of function, which is this action to message mapping, we might just as well simplify the problem and say, okay, let's think of delegation as a restricted delegation problem, right? The sender just chooses a set of actions which are permissible and then hand over the keys to the sender. The sender cannot go outside this set, but he can choose any action within this set. Right? Yes.
So is the argument essentially that for the receiver, given any state, so long as an action in this set is being played, that is weakly better than any action outside of that set being played?
No. I mean, it depends on what you mean by it's better for the receiver, right? Ex post, after receiver has learned theta, for some theta, he may find that, some action outside of this set would have been better for him. We are not saying that won't happen. There are no regrets after the fact. No, there can be regrets, right? But of course, if he optimally chooses a set like this, and if ex ante, before learning theta, he finds that he, by restricting the actions to some set like this, serves his interest, then by definition, the answer to your question is no, right? So generally, restricting actions to a set will be ex ante better to him, but ex post, there may be regrets. Ex post, sometimes he may find that, some action outside would have been better.
Okay, sir.
Okay, now, so if I have convinced you that we can think of the full mechanism design problem as simply a problem of deciding or choosing a restricted set of actions and then delegating, yeah, then what is that restricted set? What does it look like? Yes. Now, before I tell you that, if you look at the cheap talk game, the cheap talk game is effectively a mechanism where the set of actions becomes reduced to a finite set of actions. These are the equilibrium actions that arise in the cheap talk game. Our A1, A2, ANs, right? If you take a step back and abstract, that's what the cheap talk game creates, right? The sender essentially in equilibrium looks at a finite number of action choices that he can bring about. And those are the equilibrium actions of the cheap talk game. So it's that sort of restricted delegation when there's literally no delegation, right? It effectively boils down to it. The other comparison that we were doing, the other option, is unconstrained delegation. So the receiver just tells the sender, you can do whatever you please. The entire Z01 action space is open to you. You decide. All right. Now, the question is, what is the optimal mechanism in terms of these sets? Right? If you could restrict the set of actions in any which way you want, then as a receiver, how would you want to restrict it? And the answer to that is given by this problem. Okay. At least in the uniform quadratic case, which we have been dealing with, the truly optimal mechanism, the globally optimal mechanism, is some kind of restricted delegation. It's delegation with a cap. Yes. So specifically, what the receiver would want to do is say that the sender can choose any action, but not an action higher than 1 minus b. Right? You can choose anything less than 1 minus b, up to 1 minus b, but not more than that. And then you hand over the keys. Yeah. Now, this is true for relatively small biases less than half. If the bias is really very big, then this is not the case. Once 1 minus b hits half, after that point, the optimal mechanism is basically choosing half no matter what. Right? But anyway, that's not terribly interesting for this range of biases. This is what the optimal delegation looks like. Now, I'm not going to do a full proof of that, but I'll show you why I'm claiming at least I'll prove the claim about the cap. Okay, that if you could do unrestricted delegation and restricted delegation, at the very least, you would want to restrict the set of permissible actions to some upper bound, and that upper bound is 1 minus b. Why is that? Let's think of all delegations of this form, where the receiver says, I'm placing a cap of a upper bar. Within this cap, you can choose any action. That's what he says to the sender. So then what will the sender's choice be? For every theta, the action will be theta plus b, as long as theta plus b is less than the cap, right? Then the sender just chooses what he ideally wants to do. If theta plus b is greater than the cap, then the sender will want to choose an action as close as possible to his ideal point, which will be the cap itself, a bar, right? So it's a step function. Now, given this is going to be the choice rule of the sender, we can calculate the expected payoff of the receiver, right? And in doing that calculation, we have to have two parts to the integration. One is in the range 0 to a bar minus b, because in this range, the first line, action choice is theta plus b. That is the relevant one for this range. And for this higher range of thetas, going from a bar minus b to 1, the cap is binding for those values of theta. And so when we are doing the integration, we have to take the action choice to be a bar, not theta plus b, but a bar. So you break it down into these two parts and you do the integration, and then you get an expression, which is this, right?
So, but we started with a discrete set of actions, like
No.
A1 to AN.
I probably confuse you with this slide. This is where your
Yes, sir.
comment came from. No, what I'm saying here is, if the receiver doesn't want to exercise any commitment whatsoever, just says that I'll go ahead with the cheap talk game. I'll keep all power in my own hands. I will not divest any power. Just tell me what you know about theta. Let's play the cheap talk game, and then I'll decide. That is equivalent to outcome equivalent to the receiver committing to this finite set of actions.
Yes, sir.
Right. Now we are moving ahead. We have moved ahead from them. We have said, okay, we don't want to restrict ourselves to playing the cheap talk game or delegation without any restrictions. We want to think of the absolutely optimal mechanism. Yes. And then I said, you can think of the optimal mechanism in terms of, restricting the action set in some way, right? Any general. And that is the exercise we are doing now. And I'm saying that, okay, if you allow yourself as a receiver to any kind of restriction of that action set before the game starts, and then let the sender decide, then the absolutely best way of restricting it is to put a cap, and that's it. No restrictions below the cap. Only restriction is that it can't go over the cap. And the cap turns out to be, in the uniform quadratic case, 1 minus b. And so the cap is more severe, the greater is the conflict between them, the bigger is the bias. That's one qualitative part. Right? So cheap talk, there is value to going beyond cheap talk, or just playing the advisory game between sender and the receiver. Right? There's value to even going beyond unrestricted delegation. The absolutely best commitment from the receiver's perspective is some sort of restricted delegation. Yeah. So this is, by doing the appropriate integration, you get this, which is like a cubic in terms of a bar. And now if you want to choose a bar optimally, just set the derivative of this equal to 0. and that'll give you optimal cap, which is 1 minus b. Yes? And in his paper, Descent shows that, as I said, this result generalized to sort of distance-based preferences, not just the quadratic preferences, but any kind of distance-based preferences, which is where the disutility is convex in the gap between action and bliss point. The distributional assumption, the fact that we have taken it's a uniform distribution, it's not knife edge. It's not like, if we take some other distribution, it won't happen. But uniform distribution has this feature that it has the fattest possible tails in some sense, right? At least in the class of like single peak distributions. It has very fat tails. So that means that the range of possibilities is very well distributed, right? Outcomes which are closer to the mean or expected value are about as likely as outcomes towards which are far away from the expected value. And that actually makes what this delegation to be more attractive, actually. Right? And there's some, anyway, this particular thing that, it has to be a delegation with a cap has not been terribly generalized as far as I know. It has been somewhat generalized, but not too much. Okay, any questions? Now, instead of thinking that the receiver kind of creating a mechanism, creating a commitment, we can also think about the sender making a commitment, right? And we talked about a very simple form of commitment, which is absolute honesty, right? Somehow commit to a mechanism which says that it will fully reveal the value of theta, the truth, the whole truth, and nothing but the truth. Now, just as in the receiver's case, we did a more nuanced exploration. We can also do a more nuanced exploration of commitment possibilities from the sender's side. So for example, are there more restricted kinds of honesty that the sender wants to commit to? For example, the sender could commit to a mechanism which says, as long as theta is between 0 and 0.8, I will reveal the exact value of theta. But between 0.8 and 1, if theta falls there, then I will just say that it falls in this interval and then I'll not reveal anything further. Theoretically, you can think of partial honesty mechanisms like that. Yes. And the question we can pose is, if the sender can commit to all kinds of information disclosure strategies or functions, what will you want to commit to? What's the absolute ideal? Yes. Is it full honesty or is it some partial honesty? Now, the answer there is certainly for a uniform quadratic case, it's going to be full honesty, right? No ifs and buts, no partial thing, no cap, no nothing, no restrictions. Now, one way to think about it is to, again, formulate the problem as the sender committing to some function, some message function. It says, okay, I'll follow this function in my report. If theta takes some value, I'll plug it into this function. Whatever this function spits out, that's what I'll report, right? And suppose he has a way of committing to that function. If the m theta function is strictly monotone, then it'll be invertible, and then basically this captures complete honesty. Yeah. But if it has flat parts, then that means certain intervals are not disclosed. So for example, if our message m theta function looks like this, for example, what does that mean? That means if theta falls in this range, the function is monotonic. So as a receiver or listener, I can invert and figure out what from the message, I can invert and figure out what the state of the world is. But if theta falls in this range, in this entire range, there's a flat message. So that means these range of values of thetas are lumped together in the message, right? You can't tell them apart. So in this picture, if the m theta function looked like this, there is full revelation in these red intervals, and there's no revelation of theta in these other intervals. You get to learn whether theta is in the interval or not, but nothing beyond that. And if you play the cheap talk game, that would basically means that this m theta function becomes a step function, right? It's just several flat lines, flat segments. Okay, so what is the optimal thing? And the optimal disclosure policy and the commitment is full disclosure. Yes. Now, why is that? Because let me not give a full proof, but I'll tell you the idea, and more importantly, the intuition. The idea is as follows. Suppose theta has been learned that theta falls in this flat segment, right? In this interval. So according to the function m theta, nothing is supposed to be disclosed within this interval. What if the flat segment is replaced by a monotonically increasing segment? So instead of keeping this range opaque, the sender chooses to reveal everything, right? You can show that So basically, if you go back to those welfare calculations, right, this sender's expected disutility is the receiver's expected disutility plus beta b squared. If he commits to honesty, it'll simply be b squared. It'll be lower, right? That logic applies to the whole interval as well as any sub-interval. Yes, it's the same logic. The receiver always gains from gaining more information, and the sender's payoff is the receiver's payoff plus some factor. So anything which reduces that is good for the sender too. Okay. Now, let me skip this and get to a third kind of issue, which is free speech. Okay. So think of a sender-receiver game. So so think of the sender here as the media, let's say, the free press. Okay, the free press learns some information about the economy, the fundamentals of the economy, right? For example, are there recessionary or inflationary pressures? What is the world market like? You know, if the world market is going into a recession, that will affect India and so on. So the media or the financial press gets some information about theta. And the receiver is the citizen. So if there's a free speech environment, then the media can, without any restriction, report to the receiver, to the citizen. Okay. Now you can imagine that the media or the sender doesn't have exactly the same preference as the average citizen. Yes. For example, the media may have some, maybe captured by some business interests, corporate interests, what have you. You can tell a story. And that means that the communication between the media and the public and the reader or TV news watchers would be not as simple, right? It'll be basically a cheap talk game. So the media may want to withhold some of the news, the bad news or the good news, what have you, right? So whatever, some cheap talk game plays out, okay? And the public listens to the economic information and makes decisions like, for example, how much to save or how much to invest in the stock market, something. Now, that's what's going to happen in a free press situation. But now we can also think of what if there's a government which can come in between communication between the media or the sender and the receiver, right? So this is an alternative game. This is a game without free speech, where there's censorship or some sort of screening of the media's message. What does that mean? What kind of game is that? That means that the state of the world is known by the sender, the media. Then the media cannot directly convey it to the public. The media has to first pass it through a censor. So the media basically sends a message M to the censor. And effectively, the censor then passes on some message M prime, which could be a different message from M to the receiver, the general public, right? So communication has to be routed through a censor. And let's say the general public's preference has B equal to 0. The sender has a B, and the censor has another bias B prime, which is larger than B. Okay, so the censor is more distant from the public compared to the press. So this is the game. So the question is, which game is better, right? If this game is better without the censor sitting in the middle, then that means that's an endorsement, that's a recommendation for having a free speech environment, to have something like the First Amendment of the US, right? But if this game is better, then do away with the First Amendment. Then the government tries to regulate the speech. Now, when I say better, the natural question is better according to whom? The press, the public, or the government? And my point is going to be that in general, especially with uniform, I'll show you with uniform quadratic preferences, it's better for everyone ex ante, including the government. So censorship is self-defeating. That's the point. That it leads to so much information loss that ultimately it doesn't even serve the interests of the entity, the state, the government, whoever it is, who's trying to censor the information or regulate the information. Yes. So, what's the basis of that? The basis of that is as follows. If you look at this censorship game, right, how does it go? What are its equilibria like? What the censor can do, all right, at best, mind you that theta is only known directly by the sender, not by the censor, not by the final receiver. Only this player, the blue player, has direct access to information about theta. So the censor, the most it can do is lump some of the messages that it gets from the sender. So for example, if the sender creates 3 ranges, 3 intervals, say theta is from a high, middle, or low interval, what the censor can do, if it wants, is lump together the low and the middle interval, right? So even when it has heard from the sender that theta is in the middle interval, it can tell the public, no, it has come from the low interval. So now, if we have an equilibrium where that happens, right, where in equilibrium the censor lumps some of the messages coming from the sender, then we can create a corresponding equilibrium where the sender originally lumps his own messages. If he knows that these two messages are going to be lumped together by the next guy, then he might as well lump them himself and not bother to make that distinction. So if his messages M1, M2 are both going to be reported as some message M tilde, then he might as well do that amalgamation right at the outset, right? So there's no loss of generality in considering equilibria where in equilibrium, the sensor does not manipulate or distort any of the messages or lump them together, right? All the anticipated distortions have been done at the beginning and is incorporated in the sender strategy. So when we look at partition equilibria, essentially, there are two sets of incentive constraints. One is the standard one of the two-player game, right? The sender has to be indifferent at the cutoff points. If the sender himself is breaking it up into a number of intervals, then at each cutoff point, he has to be indifferent. That's one. And the second thing that we can impose is the no censorship condition, that the sensor will not, in equilibrium, want to lump any of the messages of the sender, right? That condition can be imposed without loss of generality, as I just said. Now, if we have these two sets of indifference conditions, incentive constraints, then what are the equilibria? Now notice in the original two-player game, we had only the first set of constraints to be satisfied, not the second. When we have the three-player game, the only additional thing is the second condition. The additional constraint comes in. So anything which satisfies, any partition which satisfies both of these will also satisfy the first of these, right? So any equilibrium of this three-player game will also be an equilibrium of the original two-player game where we have free speech and there's no censorship, yes? But the reverse is not going to be true. Any equilibrium of the two-player game without censorship is not going to necessarily be an equilibrium of this because there's this extra no censorship condition which also has to be satisfied. Here's an example. And you can go through the details. Let me just tell you. Here are taken B to be 1/16, and the sensor's bias is bigger, 1/8. Now, if you look at the free speech environment, the two-player game, sensor has removed himself from the picture. Then there's a three-interval equilibrium. You can work it out easily, right? The cutoff points are 1/12, 5/12. There also happens to be a two-interval equilibrium where the cutoff point is 3/8. So for this bias, 1/16, you have these two non-battling equilibria. Yes? Now, if you create the three-speech censorship game, if you bring in the sensor, you can show that only this equilibrium survives, not the three-interval equilibrium. If you have the three-interval equilibrium, the sensor will want to lump the messages M1 and M2. All right? And that'll break it down. Whereas here, the sensor will not want to lump those messages. Okay, so since I've run out of time, I'll leave it to you to check what I just said, right? These conditions. Now, but the main point is that the moment there is a sensor, the more informative equilibrium breaks down and the less informative equilibrium survives, right? And remember, when we did the welfare analysis, we saw that the most informative, the equilibrium with the largest possible number of intervals, is the best one, ex ante, for sender as well as receiver. And so therefore, the better equilibrium has disappeared due to censorship. Only the worst of the two equilibria remain. Now, our welfare analysis also shows that ex ante, the payoffs of the players are perfectly correlated, right? Each player's payoff is, the receiver's payoff plus B squared, where B is their bias distance with the receiver, right? So anything which improves, which makes the receiver better off ex ante, will also make the sender better off ex ante, and also make the sensor better off ex ante. Yes. So that kind of completes or rounds up my argument that in these censorship games, the censor actually shoots himself in the foot at the end of the day. Because the censor is there, that means communication possibilities get much more restricted. That means less communication is credibly conveyed. That means decision making is less informed, and that harms the interests of all parties. Right. The ultimate expression of this, this self-defeating nature of trying to manipulate information comes from the Aesop story, if you remember. There's this, the boy who cried wolf. Yes. Most days the boy would go up there to tend to his flock of sheep, and just for fun, he would falsely cry wolf, and the villagers would come running. And one day the wolf actually came, and nobody came to his rescue, and got eaten up. So that's due to a lack of commitment. Yes. The fun which he had by falsely crying sheep was more than outweighed by the day when he had a disaster, because the wolf actually came. And that's the sort of lesson which carries over to all of these cases. Okay, I've run over time, so any questions?
Sir?
Yes.
I just have two clarificatory questions.
Yes.
So typically when we make these cutoff arguments, so for instance, the one we made about theta t,
Yeah.
Indifference at the threshold,
Yes.
these arguments typically involve using the continuity of payoffs, right? It's because of the continuity of the payoff functions that we can